All right, cool. So I'll just get started. I was supposed to give a slide, a little background on myself. Senior Director of Data Science and Engineering at Malwarebytes. I guess I'll start with a little bit of background on Malwarebytes before we get into like what we're actually going to do. So I got a little short video. Oh, no sound. Okay, so that's what we do. We defeat malware. This is our CEO, Marcin. Really, the background is that he believes that everyone has a right to a malware-free existence. We talk about the mission behind everything that we do around data, big data, is really to move forward and create the best disinfection and protection solutions to combat the world's most harmful threats. Okay. So onto the talk. Really, we're just talking about big data, and I got hired at Malwarebytes almost a year ago, and we talked about covering 4 areas: product analytics, customer analytics. We needed to build out a threat data lab, and there's something that was new to me, which is called threat marketing, right? Which is all around discovering and understanding the landscape of malware out there. I think almost everybody here knows about product and customer analytics, so we won't talk about that. We'll focus almost everything that we talk about today on the threat side, because I think that's actually what makes sense. The key to detection in the malware or the antivirus world is really that there's a huge amount of data that you can collect, right? We actually are pretty fortunate that we actually give away our software for free. There's a huge free user base, hundreds of millions. And so we have a mountain of data, and it's basically impossible for us to know what parts of the data are, or at least before we came, it was impossible for the company to know, the researchers to know what parts of the data were important and interesting to look at. And so what we did was we figured out that sort of the real-time happenings of the world, the real-time threats that are attacking the globe at this moment, it really helps us to focus our research effort in that very minute, hour, and day, right? That's where we need to spend our researchers' attention. And so there's basically five keys to threat detection that I had to learn, which is basically to be first. And so what that meant was that speed really did matter. In other landscapes, I'm a traditional data warehouse guy. We had things like KPIs, and we'd manage to exceptions. In this scenario, really speed does matter. And so we started thinking about, wow, should we do kind of a Lambda architecture? This sounds like a Lambda problem, right? We got all excited. If you take a look, my friend Jay over here, he did a big article on Lambda architecture and why it's garbage and whatnot. But the key to Lambda architecture, traditional Lambda architecture, is that there's some downfalls to it, right? You're actually implementing your code 2 times, once in the speed layer and once in the batch layer. And so we looked at that, we said, that's probably not what we want to do. We don't want to have everything in the speed layer and also everything in the batch layer. But we do need to have this speed give us some direction, give the researchers some direction on where they can focus their efforts. And so what we developed was kind of almost what we call internally like a Lambda 2 architecture. And what we did was we created a very thin real-time layer. We pushed a lot of the processing back into Kafka and Kafka streams. That was sort of a common processing layer. And then we really built out the batch layer in a traditional way, sort of using big data technologies like Hadoop. And I'll let Manju talk a little bit about that. And then, of course, we do some serving like unification in order to make all of this work. All right, I'm the talking guy, so I'll kind of get out of the way, and I'll let these cool gentlemen dig a little deeper. So I'll introduce Manju, Senior Manager of Data Science and Engineering. He'll talk a little bit more about architecture.
Thank you, Darren. So my name is Manju. I'm a senior manager in data science and engineering group in Malwarebytes. Before joining Malwarebytes 8 months ago, I was working in a technology services company called Infosys, building data warehousing, business intelligence, big data, and data science solutions for Apple. So At Malwarebytes, we have multiple technologies to protect our customers from world's most harmful internet threats. We have anti-malware, we have anti-ransomware, anti-exploit, malicious website protections. We also have products for business enterprises as well, like breach remediation, endpoint protection, and also other products like adware cleaner. So really the goal here is to make sure that we provide layers of protection for our customers so that they can navigate through the world of internet without any issues. So if you look at it, when I joined Malwarebytes, one of the interesting use cases that we found that our security research team as well as our malware intelligence teams are grappling with is on how to detect, malwares or malicious payloads that are being delivered through exploit kits. So if you look at it, we have a anti-exploit technology that protects our customers from this malicious software that are being delivered through exploit kits. What is an exploit kit? Exploit kits are basically, a software which runs on the web servers and that takes advantage of security holes on the client machines. It detects the vulnerabilities. For example, it could be a Flash exploit or a vulnerability in Flash or Java runtime environment or other cases, and then uses those vulnerabilities to deliver malicious payload to the client's machine. So we actually had to look at what kind of threats are coming in through these exploit kits and then provide certain capabilities for our security research and malware intelligence team so that they can identify what's going on and how we can protect our customers from those harmful threats. So what our security research and intelligence team really wants to know is, if you look at it, security always wants to understand what's happening in the world out there. Like, what are the most harmful threats that are affecting more people in more places, in more ways, on more days. So if we can quantify that information, then we can actually protect our customers from those harmful threats. So in order to answer that question of how much threats are happening for more people in more places, in more ways, on more days, we have to look at certain parameters. Some of them are real-time parameters and some of them are batch parameters. For example, we need to look at the velocity, so how fast these security threats are happening across the world, and what are the geographical locations that are being targeted for these type of threats, and also look at what are the domains from which those security threats are coming in, and also look at if our products itself is being used by criminals to see if they can develop those softwares to bypass our products. So there are certain things like criminals will use our product and see if their malware is getting caught or not, and then they release it out in the wild. So other things like we had to give our users capabilities such as research. So look at all of the historical data sets, have some data labs where they can experiment on the rules that they are defining, and then create a leaderboard so that they can have trends. For example, what is the most used exploit kit in the last 2 weeks or in the last 1 month? Is it the neutrino exploit kit? Is it the sundown exploit kit? Is it the rig exploit kit? So on and so forth. So we had these requirements of both real time as well as batch. So we wanted to look at how we can address these needs. So we had to develop this infrastructure and solutions that kind of provides both real time and batch capabilities and a unified view of both real time and batch, so that the research team as well as intelligence team can find out what's happening around the world and then make sure that our products are actually capable of protecting our customers from these threats. So what are the challenges that we had in building this solution? So when I got in, basically if you look at it, Malwarebytes don't have access to resources as most big companies do. So we have to be smart in way in which we actually do build our infrastructure and provide capabilities and cutting edge technologies to our research team. So one of the parameter that we set out for is time to market. So how do we look at building solutions that can be deployed quickly? So we looked at this parameter and then we looked at cloud computing. So if the New York Times famous columnist Tom Friedman says that back in the old days, people used to locate themselves on the banks of Amazon River, and now people are locating themselves on Amazon.com because that's where the capabilities are being provided, cutting edge technologies are happening. So we looked at this and we said, okay, we will locate ourselves in Amazon Web Services, and there are a host of technologies, and Amazon is trying to crack the real world problems in a right way. So we chose Amazon Web Services as our cloud computing platform to deliver this big data infrastructure. The other thing, that challenge that we had was, with respect to dealing with high volumes, and also with respect to keeping the costs down. So one of the things that we did is we looked at how this really the new internet based companies, how they are structuring themselves. So we looked at tools, and we really the Kafka came out as one of the tools that can be used for streaming ingestion. So Kafka is being used by Netflix, LinkedIn, Twitter. So we looked at that and we said, okay, we will embrace open source technologies to solve our problems. So we located ourselves in cloud computing space, we embraced open source technologies. And when we were doing this, we said, we have to be extremely careful on where we focus our energy and attention. The reason is there are so many things that's going on. There is so much, the pace of acceleration in digital technologies is happening so quickly that it is very important that we focus our energy and attention in solving real world problems. So we thought, why not we take some of the learnings that is happening in the traditional space, and then use those learnings, those tools as well, in order to build our infrastructure. So the workflow orchestration, so we didn't want our engineers to spend most of their time on job failures or how to schedule jobs. So as in one of the keynotes earlier in the morning today, Ted was actually speaking about, from Mapper was speaking about, if we make everyone focus on everything, nothing can be done. So we have to make sure that everyone focus on certain problem statements. So we said we will look at this whole underpinning this workflow orchestration through time tested software. So that's where BMC workload automation came into our minds, and then we tested out, and that kind of helped us to make sure that the workflow orchestration, the SLA management in the big data space can be handled by the tools that are actually solving this problem in the IT world. So we chose with BMC workload automation as the software. So if you look at our current architecture, so this is how it looks like. So we have tons and tons of installations that are out there in the wild. So these products that are installed in the customers is sending us anonymous data collection is happening from customers who chose us to send this data set. So we collect this data set, we send it through Amazon load balancing. We also have our custom API to accept this request, and then we routed this through Kafka topic, and then from Kafka topic we actually route it to a speed layer through technologies of Kafka Stream and Kafka Connect, and then using HBase we actually compute all of our real-time indicators. We also fork this data set into a batch layer, and then in batch layer is where we do transformations and enrichments, and then we make those data set available to users on a Cloudera Impala, so that it can be accessed for reporting, visualization, and as well as other purposes like research and interactive SQL querying. So while we do this, basically what happened was we wanted to embrace all of the things that's happening out there in the big data space, like ephemeral clusters. So we partnered with a company called Qbol, which kind of helps us to build ephemeral clusters. So it can spin up a cluster and spin down the clusters, so that we can actually have clusters only for the amount of time that we need, so that we can keep our cost as well as down. So we have ephemeral clusters which does our computing depending upon the volume that we have, the nature of data, and then the time it takes, it spins up the cluster and spins it down. So Qbol helped us to build this ephemeral clusters, and all of this, we underpinned this entire technology using BMC Control M batch automation. So what it does is it gives us capability to manage our SLAs, as well as it gives us capability to stuffs like predict whether our SLAs or whether our jobs are going to complete on time or not. So we have used the speed layer and then batch layer, and we have provided unification API, and from then we have actually given capabilities to our security research and intelligence teams to dig into the data, look at the real-time indicators, look at the historical trending, look at leaderboards, and then make decisions on where to spend their focus on. So we are not stopping there, so we are also actually looking aggressively on where we can embrace future. So if you look at what's happening in the big data space, basically a lot of things that can be managed, we are actually trying to give it to the people who do it best, so that we can actually focus on the real engineering problems. So one of the things that's happened is Amazon has come out with Amazon Athena, which is like SQL access, and it's like a serverless architecture. They manage everything, and we just have to give our SQL queries, and then everything goes after the S3, and then it computes. So we just pay for compute. So we are trying to aggressively pursue in future architecture as well. Look at serverless architecture. Look at how we can use Amazon DynamoDB. Look at how we can use control M even in the speed layer in order to do data quality checks, and then in the batch layer for SLA management. In that way, we can actually focus on real world problems, whereas all of the stuffs which have already been solved, like workload automation, those can be used by the champions. Like for example, BMC, it has been in the leader position in Gartner Magic Quadrant in the workflow automation space for quite some time. So we want to actually use capabilities. We want to make sure that we associate with the best to become the best. So we are aggressively pursuing all of the newest technologies also in our future architecture. I would like to now call upon Sujay, who will give you a little bit more deep dive into the engineering aspects of what we are doing using this workload automation in this Lambda architecture.
Yeah, that slide makes me nervous. Thank you, Manju. Good afternoon, everyone, and thank you for joining us. Before I deep dive and get into the weeds of it, I just want to take a minute and give a brief about my background and what do I do on a day-to-day basis. I joined Malwarebytes data science and engineering team with about 10 years experience in like typical data warehousing, implementing solutions at very large scale from companies like Apple, Infosys, and very recently I was at GoPro and lucky to be a part of team which built big data platforms from scratch. So what do I do on a day-to-day basis? I'm a typical big data engineer, and my tasks involves profiling data, ingestion, streaming ingestions, batch ingestions, ETL, transformations, stateful transformations, stateless transformations, aggregations to support typical dashboarding, decision support systems, and support. Support would typically mean performance enhancement, catering to the needs of our research and intelligence lab, etc. So let's take a quick look at what a tech stack looks like. For our platform, at the center of all of it, we have Hadoop. And as most of you know, any big data platform is not just one technology, a few technologies. It's actually a combination of multiple technologies and multiple tools working in harmony. So if we pause for a minute and take a look at this, it becomes very clear that intermodule communication or wiring between the tools can become extremely complex over time and has to be dealt very early and with caution. If operational efficiency is something you really care about, keeping in mind the pace at which all the open source technologies are evolving, the technology adoption rates, growing complexities, etc., it's very obvious that something like workload automation or orchestration cannot be left as an afterthought. So I know what most of you are thinking, like, are we taking workload automation too seriously? This is exactly what I was thinking about 2.5, 3 years back, and I learned it the hard way. You hit the ground running, you start delivering on projects, you start adopting new technologies, wiring new tools, and within about a year or two, you would end up with an architecture that would look something like this. It's a total chaos. I'm sure few of you have gone through this phase. So how do you like retrofit something into this? How do you even do an impact analysis? For that matter, how do you even document for something like this, if that's a thing you care about? So it was very clear that we needed something very simple, scalable, reliable, and as Manju said, something that is time proven to manage our eventing framework or orchestration layer, call it workload automation. Preferably something that understood big data and the semantics of distributed computing natively. So once we had established that we needed to invest time and effort into building out this like workload automation, like what next? Build or buy? Do we build some or do we buy some? A simple Google search like build versus buy will give you top 5, top 10 evaluation parameters, decision metrics, etc. Also, as an engineering team, we really didn't want to spend too much time doing stuff or like reinventing wheels. Uh, as an analogy, like in the modern times, if you're a fast-growing aggressive company like Malwarebytes, who do you think would invest time in building their own email service or instant messaging or version control repository? I don't think anyone would do that. So when you think about all this, it made our decision process very easier. We set out to buy. Some brainstorming sessions, some architectural discussions gave us more clarity on what we actually needed out of the tool and what was nice to have, need to have, and nice to have features. On a lighter note, if you look at this slide, I've tried to make both the faces smiling because engineers love building things, and with proper justification, management don't have any problem, throwing out some cash and buying tools. Okay, now that we decided we set out to buy a product for this, like who's the best? That's the next big question. We did some market research, online research. We networked with a lot of folks in the community. And from our past learnings, we narrowed down our focus on few of the technologies that are listed here. Sorry for the timing. It works. I'm so sorry. One last time, I promise. Okay, because it's showing something else here. As you can see, most of you can relate to few tools that are laid out here. Some things are very obvious, like Jenkins will get you started, but then when you think about scalability, it becomes scary. Cron and file watchers, it's free and like developers' favorite, but then when you start dealing with complex interdependencies, it tends to become a nightmare. There's a couple of interesting names out there, like Apache Airflow. I heard AWS has an offering for scheduling that they are offering recently. But then, as an engineering team, we didn't really want to invest any time on experimenting on any of the tools which are in incubation stage. We were looking for something that was like time proven. Also, the big thing that we're looking at was who actually had focus and thought leadership on big data. And when that happened, a lot of things slowly but surely started fading off. And that's how we decided to go with POC for Control M. I started reading more about it, got my hands on, and the start, I must confess, wasn't like really great of what I was like expecting. I'll just take a minute and explain you guys like what are my first set of emotions that I went through on day one. It was GUI only, and I'm not a GUI guy. I didn't really like GUI much. And it worked only on Windows. For someone who has been working on Mac all his life, that was driving me crazy. And of course, there's this apprehension of unknown because none of us had tried or tested this. And also, my biggest fear, I just didn't want it to be another IT tool. Imagine ticketing, approval process, change release windows. I mean, you go into a tailspin and never come out of it. Anyways, I convinced myself and my team, and we deep dive, and we thought we'll go ahead with POC for Control M. So 2 sprints, about 4 weeks into POC, it completely changed the way I looked at the product. So I'll take you guys through a few of the values that we found in a short 4-week period of POC. Control M for us was very reliable. At the end of POC, I just went there and talked to my DevOps engineers and the developers on our team and asked them, how much time did you actually spend on this tool? And to my surprise, nobody had actually spent any time. So it didn't require any maintenance, it didn't require any curating, it was perfect. It was very reliable. Scalability. When I did a case study for this, I happened to talk to a lot of customers who have been successfully using this tool for more than a decade, some of whom have been running close to 150, 200K jobs, and they're doing it flawlessly. So scalability was never a question. Hadoop. I kept saying before that we wanted something that understood Hadoop natively. The reason I put it up there is because Control M could talk to Yarn, if that happens to be your resource manager, natively. It could aggregate Yarn logs, it can talk to Yarn. When you kill a job, it actually initiates a Yarn command to kill the MapReduce job, and not just the wrapper script. It can understand distributed file system, it can do Hadoop HDFS file watchers, distributed copy, Hadoop streaming, Spark jobs, etc., etc. I put learning curve as a value primarily because we didn't want engineers spending like weeks and weeks trying to get comfortable with the tool just for workload automation. It was very easy for us. It took us a day or two to hit the ground running and about a week to get comfortable with it. Support, again, I put it there just to let you guys know that this is one tool who stand out when it comes to support. Every time we had a check-in call or an architectural review call, we were put in touch directly with the big data engineers from that team, and it was a very pleasing experience. These are a few of the values that were kind of neat to have for us. Apart from this, we got a lot of things out of the box from Control M. Really great tools, I would say. I would like to highlight 3 such values today. First up is batch impact analysis. This is a pretty badass tool. What it does is it smartly predicts when your workflow or a service would complete. It takes into consideration all your historical statistics, weekly, monthly, volume workloads, is aware of all your global parameters, etc. And we loved it. There's something called self-service. As the name goes, self-service is a capability for all those non-techie analysts to go look at a workflow and then restart or place a file and rerun a job, monitor it, and be aware of what's happening to SLAs. As an engineer, I don't want to waste even a single minute of my day trying to answer somebody of all these like operational questions. When is this completing? What's happening, etc. We like that too. And these days, they're working on something called as an automation API, and we loved it. The reason I say we loved automation API is because it gives you the CLI capabilities for all those non-GUI guys, if you're into it. It gives you an API capabilities. Basically, your jobs become code. So once your job is a code, you can play around with it. You can embed it with a part of other code, etc. It makes working on Mac, Unix, and other platforms very easy. Eases your continuous integration, GitHub, Jenkins, or whatever you use. I use the word eases only because it was capable of doing this even before that. And it gives a great feature parity with the GUI that they have. A lot of jibber jabber. Let's actually dive in and see what it takes to build a Control M job using the automation API. It's a simple human-readable JSON definition that you can use to define a job. On the left box, if you can see it okay, you just define the categories of the job, like what application, what sub-application, where do you want to run it, what is the actual schedule, how do you want to deal with it if it fails or if it underruns, overruns, etc. And on the right side, you can define what each of the tasks does. Like, the first command job happens to be just an echo job. The next job here, in the example, calls a script that does something. And then you can define the actual flow of the job or the workflow. Running is again straightforward. You just call the API with the command and point it to the JSON file you just made. It gives you back a run ID and a status URI. Using that run ID, you can manage and monitor the status of the workflow. Now, you must be wondering what's that status URI. For all those of you who love to work on GUI and who love colors and like to see things visually, this product has a wonderful, wonderful GUI which is completely. I think I was really impressed with that. It gives you a full feature parity too. It looks something like this. You can see the workflows, you can see the color coded status of what's happening with each jobs. You can group them with an application, or you can have your own custom grouping, etc. Honestly, as an engineer, I don't spend any time on this tool on my day-to-day basis. It's so wonderful that it's kind of a tool that you set and forget type of a thing. So now looking back on why we chose to invest in something like this, I think it has paid off really well, because I didn't want to invest any time in doing this operational task. It has given me a lot of time to focus on dealing with actual problems, like how do you handle offsets in Kafka efficiently? How do you fine-tune your ephemeral clusters? Or like what are the best combination of spot versus on-demand nodes for a heterogeneous cluster? Or when my manager pressurizes me to start thinking about serverless architecture, I have more time for this. That's all I had to say, folks. Thank you. Any questions?
Yeah, go ahead.
Yes. The question is it only a Windows thing? It is only a Windows thing. I wish I could show that, but then I don't have the connectivity. But then all that you can do with Windows can also be done using an automation API. Like it gives you a full feature parity. You can build the jobs, you can run it, manage it, monitor it. It almost has a full feature parity. A lot of things that runs on Windows is also exposed using a web server that you can access through Mac and other platforms. I'm inclined more towards adopting automation API because that seems to be really exciting. It gives you the flexibility to start playing with the code. Like when you talk about federation layer, eventing framework, you really want to talk to this like scheduling engine in terms of code. So I'm inclined more towards automation API, but I do love the GUI part, having spent 3 years with this. What is that? Oh no,
Yarn cluster.
it has both. The question is, does it only connect to like AND cluster? Is it? Because I was talking about it talking to Yarn natively. It supports both agent-based and agentless architecture. So all you need to do is basically install an agent of Control M on any component of your ecosystem, and then it can talk back and forth with the server.
Cool.
Thank you, guys.
Thank you.